Hi, I'm Steve McNeely, and I've decided to build a de Havilland Comet 1 fuselage from scratch. Why? Well, I'm a pilot of a modern jet aircraft, and the early jets of the 1940s and 1950s put us on course for today's modern jets. And this project, the Comet 1 project, is a tribute to the early jet age.
Let's start this amazing story. Think what aircraft were like in 1946. They had straight wings, propellers, and piston engines. They were slow, and the vibration inside was awful. That changed forever with this, the de Havilland Comet 1. All the things we take for granted, speed, smoothness, and flying high above the weather, started with this. And it flew for the first time in 1949. Most people would never guess that jet engine development started in the 1930s. After all, horses and buggies were primary in that era. And it was the British and Germans that simultaneously invented the jet engine. But the engines were extremely underpowered and suffered from metallurgy problems. By World War II, generally speaking, they weren't sufficiently developed for wartime use, much less commercial use. But with newfound swept-wing technology, the jet engine was the gateway to high speeds. When the war ended, Britain was on its knees, recovering as a battered, war-torn nation. But their innovative spirit was tremendous, especially with producing weapons. Plus, they held the key to the future, the jet engine. But it was actually during the war that Britain realized America's dominance in the transport aircraft market. If Britain didn't do something about it, they'd be on the back foot when the war ended. So they made plans to lead the world with this new technology, the jet-powered commercial airliner. The proposed jetliner would cut travel times in half. As an example, the London to Tokyo route was nearly 7,000 miles, and a 260-knot propeller-driven Douglas DC-4 would need multiple stops, taking over 90 hours to complete the journey. The proposed jet airliner would travel at a staggering 460 knots, taking only 40 hours with multiple refueling stops. It meant everything because the jetliner would truly connect the world for the first time. It would be the basis for today's long-range jets traveling over 500 knots, making the same journey non-stop in 12 hours. In Britain, through the Exploratory Brabazon Committee of 1942, specifications were created for several new transport types, and by 1943, Type 4 specified a fast mail carrier with 6 passengers with unspecified propulsion. In June 1943, Geoffrey de Havilland joined the committee and championed the Type 4 to be jet-powered, similar to his company's Vampire jet fighters. By 1944, de Havilland had convinced the committee that his company was the most suited to build the jet transport, and they received the go-ahead. From 1944 to 1946, de Havilland conducted swept-wing and wind tunnel research, including construction of the DH-108 test aircraft, which helped prove low-speed handling capabilities. Definitive work on the airplane started in 1946. For market competitiveness, all development was done in total secrecy. Final design features included a highly aerodynamic shape, 20-degree swept wings, and 4 de Havilland Ghost jet engines. The name Comet was given to the airplane, which was to be the cutting edge of technology, the space shuttle of its day. In April 1949, the Comet's secret development was finally made public with a full-page statement in the company's de Havilland Gazette publication. And the first prototype stunned the world months later with its inaugural flight on July 27, 1949. By 1952, the Comet 1 became the world's first passenger jetliner to enter service, operated by British Overseas Airways Corporation, BOAC. The airplane was sleek and beautiful, cutting travel times in half. In-flight service was unmatched with fine china and champagne. Travel had become elegant, quiet, and smooth. De Havilland's order books were filling rapidly as the world's airlines had met the future. But by 1954, 2 BOAC Comet 1s, GALYP and GALYY, exploded in flight. As the most advanced airplane to date, the Comet was the first to have a full pressurized cabin flying at high altitude. The investigation found the pressurized cabins had exploded in flight, with the problem traced to metal fatigue. De Havilland's testing had been extremely thorough, indicating that the jet's service life was supposed to be much longer. But testing methodology of the late 1940s was insufficient for the jet age. Contributing factors included the brittle aluminum alloy of the skin, the thickness of the skin, punch riveting manufacturing techniques, and testing methodology. It's commonly misreported that the Comet 1's square passenger windows were the cause of the metal fatigue. This point requires clarification. The Comet 1 had rectangular-shaped windows with 3-inch radius rounded corners. The metal fatigue stresses were discovered to be far greater than estimated, and it was at the corners of the passenger windows and cutouts where the stress had concentrated. But the shape of the windows themselves was not the cause. To further the point, the American manufacturer Boeing would eventually take the world jetliner market. Their 707, 727, 737, and 757 airplanes all shared the exact same 3-inch radius rounded corners of the Comet 1's windows. In fact, the Boeing passenger windows are also the same height as the Comet 1 windows. Getting back to the story, by 1954, with the 2 explosive decompression accidents, 21 Comet 1s had been built, 2 prototypes, and 19 production models. The aircraft type's problems were exacerbated with the loss of another 5 Comet 1s in takeoff, landing, and thunderstorm accidents. It's hard to fathom 7 of 21 jets lost in 2 years of commercial use. The truth is that the Comet 1 was unbelievably advanced and very well designed, but so much wasn't known in the late 1940s and early 1950s. As one Comet 1 pilot wrote, the Comet 1 was like flying an experimental aircraft, meaning so much needed to be further developed. With the tragic accidents, worldwide news of the world's first jet airliner went from enthusiastic jubilance to sadness and dismay. All remaining Comet 1s were removed from service. It was an energetic, rapid rise to the top, followed by complete economic failure and human tragedy. With the Comet 1 program lost by 1954, by 1958, de Havilland completely redesigned the aircraft as the longer, more powerful, and highly advanced Comet 4. But the race was lost. The American companies, Boeing and Douglas, would learn from Britain's hard-fought lessons and develop the larger Boeing 707 and Douglas DC-8. With the Americans' massive industrial complex and manufacturing capabilities, they captured the world market. In many ways, it was all over for the British. What they had pioneered so amazingly was sadly lost. Today, we take for granted the phenomenally safe and reliable jets we purchase cheap tickets on. As we think of our modern jet travel, what happened to the remaining Comet 1s? Of the 21 Comet 1s built by 1954, 7 were destroyed in accidents, as mentioned. That left 14 Comet 1s returned by their owners, which were BOAC, Air France, UAT, Canadian Pacific, and Royal Canadian Air Force. 4 were rebuilt by de Havilland as strengthened Comet 1 XB models, the last flying through 1968. The other 10 were used for testing or cut up for scrap. Here's a walkthrough of the surviving Comet 1s today. The nose of GALYW exists as a past Royal Air Force Nimrod aircraft traveling exhibit sitting in a private parking lot in Germany. Little is known about this, and access is not allowed by the owner. 2 exist at the de Havilland Aircraft Museum in England. The fuselage of FBGNX exists in the new museum hangar. And the nose of GANAV is stored in a building at the time of this production. The nose of VC-5301 exists at the Canadian National Aviation Museum. And FBGNZ, later registered XM823 as a rebuilt Comet 1XB, is the only entire airframe still existing on display at the RAF Museum at Cosford. It started life as a Comet 1 for Air France and was rebuilt with a strengthened fuselage as a Comet 1 XB for the Royal Air Force.
So why build a replica de Havilland Comet 1 fuselage? Well, I did approach the museums and I asked if I could buy one of theirs. They refused, which is understandable, but I did try. Second, consider this about history. We're still digging up bones, pottery, arrowheads. and we're going to be continuing to dig them up for a long time. But what happens to a classic airplane once all examples that were built are destroyed and torn down? Well, they're gone forever. They're extinct, never to be seen again, except in photos. But that's what this project is about. It's about bringing back to life something that's almost extinct, yet incredibly historical. So years ago, I figured, well, what if I was a bazillionaire? I'd love to be so amazingly rich I could hire a team of engineers and experts and build a replica Comet 1. I figured, how cool would that be? But I also figured that's never going to happen. But then the light bulb went on, and I figured, what if? Let's start cutting wood, let's start cutting metal, let's see if we can make this happen. So that's where the story starts, which you'll see in episode 2. It's a trip back to the early jet age to see what it was like in 1952. We're building this de Havilland Comet 1 fuselage replica to have a fully functioning flight simulator cockpit, plus the forward galley area with all the equipment and furnishings, and then the forward passenger compartment, where you'll actually get to see what the square windows were like. So that's what this project is all about. It's a trip back to the early jet age. So come back to episode 2, where you'll see a lot more of how this project happened. Thanks for watching.
If you like this video, please make a donation at dehavillandcomet.com so we can continue funding the Comet project.